So we're in chapter 1C, lesson 2, where we're going to start looking at oxygen, DET, EPOC, and the effects of exercise. But before we start that, we've got some terminology that we need to discuss, just so we're a little bit more fluid with the terms coming up. So the first one we have is lactic acid. Now, lactic acid is a byproduct of mainly anaerobic exercise, because lactic acid would previously be a term called pyruvic acid. However, when there is not enough oxygen, it converts to lactic acid. And lactic acid will inhibit muscular contraction. And that's why when you get that really strong burning sensation in your legs, there'll become a point when they're unable to contract anymore because of the levels of lactic acid. Now, ironically, when you stop and you add in oxygen, you will get the pyruvic acid will be able to convert back into the lactic acid. And then this detail, it goes into huge amount of detail in A level, which if you want more information about, again, I can make a video and pop it onto the stream. But we have lactic acid, and it is a waste product from anaerobic exercise. Another terminology that we would have to become accustomed to in GCSE is about oxygen DET. Now, if we take the term DET, we know it means it's owed. Okay, so I am working in a state of exercise where I am not taking in enough oxygen during the exercise, so therefore I'm going to owe that back. That can also be described as oxygen deficit. So it's the amount of air that is required to complete the activity. And then we have EPOC. So EPOC is stands for excess, so more than. Post, so after. Oxygen consumption. So excess, so a lot of so when you're taking in a lot of oxygen at the end of the exercise, so you're owing it back to that person. And you might be needed to be able to talk about what that athlete would look like if they're experiencing EPOC, so very, very heavy breathing or gasping. You might see them at the end of a race, an elite athlete race, on the floor, gasping for breath. Now, we experience EPOC regardless of the intensity level. Just the level and volume of EPOC will depend on the volume of the deficit which we have been faced with. So for example, if I go for a very light jog, I will experience an EPOC at the end because I will have had a greater demand of oxygen than I've potentially been supplying. If I compare that to doing a 400 metre sprint, I'm going to have a much greater level of EPOC that I would need to go through. And when you go into A level, we look at two different phases of EPOC, but for GCSE, it's just need to be aware that it is at the end of an extremely intense level of exercise, and we need to take in oxygen at the end to pay it back from the ones that when we've taken it. Now, you would need to, again, as we've spoken before, we would have very clear sporting examples of where you would see an athlete experiencing EPOC, and also in athletics, always having the two different ones. Now, here we're going to look at a graph just so we can demonstrate it. So this here is our volume of oxygen uptake, so how much oxygen I'm taking in. So you can see here when I'm at rest, so my oxygen uptake is quite low. Okay, that's done in litres per minute. When I go into a state of exercise, my oxygen intake is getting much greater as I'm going up. Okay, now there will be a relationship between A and C. Okay, because what we'll be able to see is that the greater A, which is oxygen deficit, the amount that I'm owed, you would notice a much greater area of C. This would get much greater, and D would get much longer as well. So the greater the oxygen deficit, so for example, if I do a light jog for 5 minutes, I'm going to be able to recover much quicker than if I played, a 90-minute high-intensity game of football. So as a result, my oxygen deficit wouldn't be as great, so therefore my recovery doesn't need to be as long in that sense. And this is an A-level content as well, but it's also needed in GCSE. You need to be able to understand that the body needs oxygen at the end, additional oxygen at the end of exercise, and that is really to remove that lactic acid. And that's what happens here in these phases, phase 1 and phase 2. Okay, particularly in phase 2. But in GCSE, we know that this will be demonstrated by someone who's breathing very heavily, replacing the depth. Now, depending on how long the oxygen debt lasts, it will depend on how much lactic acid has been produced. So again, the greater the level, the intensity, the greater the level of the lactic acid. Now, following this video, once you've done your quiz, you're going to do a workout, a Joe Wicks high intensity interval training workout, and then I want you to answer the questions at the end. And this is going to be our introduction to the effects of exercise. So when we talk about effects of exercise, we talk about immediate, so as you're feeling during the exercise. And then for next week's lesson, we'll go into the effects after, so 24 hours and 36 hours after the exercise. How are you feeling? Now, this content will come up in your end of year assessment, and so it's really important that you're going back over this. Now, there is another layer of this information at A level, a very, very difficult content, but it is another layer. So if you're interested in it and would like to learn a little bit more about the A level side of it as well, then of course let me know. But for this in particular lesson, we're looking at EPOC, which is excess post-oxygen consumption, normally as a result of it would be a higher level of intensity. You wouldn't experience it particularly because of a walk, because I'm probably able to meet the supply and the demand. And we're looking at this production of lactic acid, experiencing oxygen debt, and some sporting examples which would occur oxygen debt, and you would see evidence of EPOC. So just make sure you are completing the quiz and you're submitting it. Remember, once the feedback is given, you can go back into your form, and I've given you individual feedback on each one of your questions.